All right, so good afternoon, everyone. So we will actually start the session now. So I'm going to share my screen. So can you see my AWS console? Can you see my AWS console?
Yes.
Okay, all right. Okay. All right. So yesterday we were looking at Elastic Load Balancer. We set up some EC2 servers. Then we looked at Elastic Beanstalk briefly. So today we will continue our journey in understanding what is Elastic Beanstalk. And also we will spend some time in understanding Elastic Container Service, which is called ECS. So we will first look at Elastic Load Balancer, because yesterday we were trying to set up something and somehow that was not working. And then after debugging, what I realized that I was connected to a different server and my registration app, the Docker container, was running on different server. So it was a kind of simple silly mistake, but that can happen. So I'm going to just start with my same setup. So what we want to understand is that what is the benefit of this application load balancer? So if you remember our discussion, so application load balancer works at which layer? Is it layer 4 or layer 7? Anyone? Is it at HTTP layer or is it at layer 4?
7.
That's correct. So it is basically at layer 7. So load balancer can basically leverage some of the features of application load balancer. So that is something which you are going to see now. So if you're following along with me, then just go to EC2. And ensure your instance is in running state. So I'm going to spin up additional. I'm going to start. Yes, please. Anyone? Any question? All right. So I'm going to start one instance which was configured with my container. And this is something which is, we saw that we configured something known as Docker containers earlier. So let me go to my edit online edit board. So I'm just going to create a new board here. So if you remember our yesterday's discussion, that load balancer one. So we have one load balancer running, and we have configured it balancer. So as to send traffic to the underlying EC2 instance. Okay. And currently there is that one application is running which is called HTTPD. Second is Regap. Now this is running inside Tomcat. And I was trying to get the access to the EC2 Regap, but it was not working because I was connected to a different server altogether. So let me see whether it's working now. So if we go to this particular IP address, so this is something which is running. And then if I go to my 8080, then I have this Tomcat which is running, and then I have this workshop register .html, and then I get this particular form. So it means it is kind of running now. Now when you want to basically like on this particular EC2 instance, there are two applications running. But whenever you actually send some kind of URL, you generally don't give this port number. Okay. So if I want to access this, then that is something which we are going to access via load balancer, because we have configured our load balancer to send traffic to the instance. So if I go to my load balancer now, so this is our load balancer. So if I go to my DNS name, so this is going to always give me this one. But if I just say 8080, what is going to happen? Should I get the page or not? What do you think?
Yes. Same page.
Yes. Let's see what happens.
We will get.
And you will see that we are not getting this page. Now, the reason for this is pretty obvious, because you might think that we expect this to forward as is, but there is a port element which comes into picture. So if I go to this particular instance, so load balancer, our load balancer is listening only on port 80. Look at this. Now it is not listening on port 8080. So that is why it is not working. So if I add a listener, then it should work. So if I just add a listener, port 8080, I say add action, I say forward to, then I'm going to select the target group. There is only a single target group because we are having only one instance. But typically, when you build multiple applications or microservices based application, you generally have multiple servers catering to that. So it is saying security group for your load balancer does not allow traffic on this listener port. So I need to modify the security group. So what I need to do, I need to come here and then go to the security group. And I need to ensure that I'm allowing traffic on port 8080. So I am going to add one more rule, which says add rule, port is 8080. And I say anywhere and click on save. So anyone, there's some kind of background sound is coming. Just keep on mute. All right. So now what I have done, I have added a listener on load balancer and also configured a security group. So if I go back here, so ideally it should work. Let's see. Let's give some time to it. So I'm just going to look at this one, load balancers, port 8080. But what is happening now? There is an issue here because our target group is actually doing health check on protocol 80. So let's see. But this is something which is this will work shortly. I'll just check that. But this is something which is not desired, because what happens typically, you will not actually put a something like port 8080 on a URL. So for example, if you go to this, I'm just going to close this. Like if you are working with an application, then you might want to just say that if I'm doing something known as app1.jd.com. So in this case, let's say this is HTTPD. So I'm just going to say HTTPD, assume that there is a domain setup, jd.com. It should go to this HTTPD. And if I just say regapp.jd.com, then it should go to this particular application. Now this is internally running on port 8080, and this is running on port 80. So this is something we want to really achieve. So this is called a domain-based routing or host header-based routing. Now, provided you have set up the domain, then only we can configure this. But in our case, the domain is not set up. So there could be another way. So if you by default, whenever you go to this load balancer, it is going to always show you HTTPD. So that is something which anyway working. But if I put something, of it. So if basically I go to, let's say this is a ELB load balancer ELB URL, and then if I just go to ELB, it goes to HTTPD. But if I just say /workshop register.html, then it should go to this application. So this if you are doing this, then this is called path-based routing. Path-based routing. So this is one type, and this is called a domain-based routing. Now this is something which is the ALB feature. So we have this, when we say we are going to use application load balancer type, then only you can use this feature. Now these features are not supported for NLB as well as Classic, because NLB is anyway working on layer 4, and Classic, this feature is not there. Okay. So let's do that. So I'm going to go to my EC2 instance, and the way we are going to set this up is we are going to create something known as target group. So currently we have only one target group, which is accepting traffic on port 80, and I'm going to create one more target group. Now that target group is created for a specific application. So I'm going to say my Tomcat based application should be configured in another target group. So if you remember yesterday's discussion, so I'm going to say, so this is HTTPD is one target group. So this is HTTPD is one target group. So TG1, and I'm going to create one more target group, and the target group will be named as, let's say, regapp. And then we are doing this because we want to achieve this kind of a implementation. So let me go to console. So let's create target group and create target group. And I'm going to say instance. Now there are various types of, whether you want to send it to IP address, whether you can also send it to Lambda function. Now this is very interesting. So even you can invoke Lambda function through the load balancer. This is something known as hybrid model. So what this hybrid model says that some request will actually go to my EC2 and some request will go to Lambda. That is something it's also possible. I'm going to say I want to use the instance type. Then I say target group name. Let's say Amod JD reg app.
Hello, Amod.
Yes.
Sorry to interrupt you. I can see the screen is blurred, so just wanted to check is it only for me or others? I cannot send message on chat.
Amol, I think it's for me also because I'm also
Same here.
now it's clear.
Yeah.
Or there is a lag today.
So the screens, then they become hazy. If you stay on the screen for a long time, then it's fine.
Now
Sorry,
I cannot see your.
Okay. Screen is blurred. Okay. So let me reshare. Yeah, can you see it now? I'll go back and start again. Can you see my AWS console?
But it's still blurred.
Yeah, but it's hazy.
Now, if I go to, let's say, what is the screen you are looking at right now? What do you see?
Right now we are seeing blur, but it's something related to target group. It's still blur for us.
I will reconnect just a minute.
Hello there. I think Amod sir got disconnected, so he will be connecting soon. Please bear with us.
Yeah, are you able to see my screen now? I'm back.
Yes.
Yes, quite good.
Is it better?
Yes. Can you switch to some other window or anything else so that we can see how the. Yeah, it looks good to me. I can see.
All right. That's fine. All right. So I'm on create target group. So I'm going to create another target group. So can you see specify group details?
Yeah.
Okay, all right. So it looks good, better now. So choose target type as an instance, and then target group name is, I'm just going to say reg app. All right, so I will just give a name, Amod, JD, reg app. And what is the port? So port is 8080. And then VPC, this is running in a custom VPC, so I'm going to use my JD workshop VPC. Health check protocol, it is going to be used based on the, in HTTP is the health check protocol. You can also specify a specific path also. If you have like, specific files to be used as health check, you can do that as well. And I'm going to keep everything else default and click on next. Now what happens when you try to create this target group, it is going to pick up all the instances or show all the instances which are having port 8080. So it picks up one, and that is something which I need to add. So there is a one button include as pending below. So I just need to add that. So what is happening is that we are adding this instance to a target group, and you can just click on create target group. So I'm just creating the target group, and it shows successfully created target group. So can you see successfully created target group on the screen?
Yes, now I can.
Okay, all right. So now this target group is there, and we are just going to ensure that the target group is, passing the health checks or not. So I'm just going to click on this, and then I go to targets. So this target group is not, is basically not configured to receive traffic from the load balancer. That is something which we are going to configure now. So we'll go to load balancers. Because the load balancer is only using one target group, just ignore that 8080 port because we are not going to use that 8080 port. Can you hear me?
Yes, I can.
All right. Somehow I'm not able to see my load balancers. So let me refresh my entire screen, whether it's sorted or not. Let's understand. All right. So if I refresh my entire screen, it started showing that. So this is my load balancer. And I'm going to remove the other listener. So what is saying? We are saying that load balancer is listing on port 80, and then I say edit. Sorry, I don't say edit there. I basically go to this view edit rules. So what is happening here? There are a set of rules. So if the request otherwise not routed, then forward it to this target group. And I can add one more rule over here. The insert rule. I'm going to add one condition. Now that condition is going to be this condition, like path-based condition, because whenever we basically use our application, we give this particular path. So what we are saying, if the load balancer URL contains this path, then please send this traffic to other target group. So I'm just going to say workshop register.html, add action, and I say forward to select target group. I say this is my target group. So click on save. So I need to check, whether I need to give this double slash this one. Just say click on save. So what is happening is that whenever it gets request this slash workshop, then we should be able to see our registration app, and that should happen through load balancer. So let's see what is happening with target groups, target group status. So this is JD. So we have two target groups. So this is going to be my target group. Let me check my status of targets. See, what generally you should do, you should actually have a target group per application. So you can host multiple applications on single instance or multiple instance also. So it is saying healthy. So what will I will go to this load balancer, and now I'm going to say when I go to this particular domain DNS name, then I get the default page. So my expectation here is that so the requested URL was not found on the server. So let's see. If I go to, let's say, put 8080. So let me see what is the issue here. So if you're configuring it at your end, just let me know what is happening with your case. So load balancer is there. Security group I need to check. Security groups looks fine, 8080. So I need to check the load balancer listener rule now. So I will go to load balancer listener rule and just check whether they requires like slash, earlier slash is required or not. So I'm just going to view edit rules, workshop register.html. I'm going to select this one, edit, and let me see if I can. Or you can also put star also there, whether it works or not. So if you look at this one page now, I think that backslash is required. So if you look at this particular URL, now this is something which is picking up our another web application, and this is called path-based routing. So that is the benefit of this application load balancer, and that is possible only with this type, not with other types. Now let's say tomorrow you have another application. So you have set up one more application. So you say my new application is here. So in that case, what you should do is that you should create a new target group. So create a new target group as target group 3. And if you have installed the same application on the same EC2, then you can use the same EC2 instance. But in practice, people will start using different instances. So this is the way you typically configure your infrastructure. You don't want to put everything on a single instance. If the single instance is down because of some reasons, then all the applications will be down. So in this case, what I will do, I will just create one more EC2 here. And then I'm going to use this EC2 instance for this target group. So this is my another EC2. And since you are using the same load balancer, now this EC2 goes inside this one balancer. So now we have multiple load balancer, but target groups are actually are used so as to decide which application that request should be forwarded. So if this is running on, let's say on EC2 on, let's say 9.9, and this is typically invoked as maybe whatever is the name, or it could be, let's say, workshop. And then you will say my new app, something like that. So this could be anything. This could be HTML file. This could be JSP file, or whatever is that file is there. The only thing is that the file has to exist on the server. So that this path has to be really valid endpoint. You can't really put any arbitrary thing over there, because that is something which application load balancer is going to evaluate and forward the traffic accordingly. This is the concept which is very useful. See, this model was not possible earlier. So what people used to do when the classic load balancer was there, just to achieve that, people used to create 3 different load balancers. And each load balancer cost around $20 per month roughly. So understood this concept of path-based routing, very important key concept. And then finally, we will also look at how to basically point this domain name or a custom domain name to our load balancer. And then if you are using custom path-based, domain-based routing can be used, and you can literally have this in your case. So typically you will see that some domains are having subdomains. They will say register dot, let's say something like that, like even Amazon, aws.amazon.com. So AWS is a subdomain, so it will go to AWS site. All right, so having understood this, we will look at Elastic Beanstalk, and then we will subsequently look at ECS. Now we have been creating this infrastructure, and you must have realized that there are lot many settings, lot many configurations, and that is something which is obviously it is very difficult for anyone to remember all these settings. So to really start practicing it, start using it in your projects. Now, so far what we have done is that we have created EC2 instance, and if we just focus on deploying the application on EC2. Now let's talk about that aspect. So whenever we deploy an application on EC2, so we deployed like these 2 applications, just simple applications. So what are the steps? So we created, assuming that it is running in VPC. So we created EC2 instance, create or launch EC2 instance, connect to it, and configure setup application. So that is something which we have been doing. And So this is one method. Now, as we are going to look at this elastic beanstalk, so elastic beanstalk is, we have seen yesterday briefly, that it is a platform and a service. So when people talk about platform and a service, they give you basically are going to abstract a lot of things, and your focus will be actually just to provide a application which you are going to run. So it could be a war file if you are running a Tomcat based application. It could be a Docker for container related file. So it could be Docker file, Docker related file. If you're running, let's say, Java application, then you might just give set up libraries and so on. If it is a .NET, then you will give it something else, and the list goes on. So that is what we have seen yesterday. So if you just want to try that out, you can basically try that out. So Elastic Beanstalk has the concept of something known as application. So those guys who are trying with me, just go to Elastic Beanstalk service. Can you see my Elastic Beanstalk screen?
Yes.
Yes.
Okay, all right. So let's say I want to deploy one simple Tomcat based application. In fact, if you have any application war file, you can literally use that. So don't put your production grade application on this account, because this account might be your personal account. I'm just going to say create an application. So the concept is very simple. So I'm just going to simplify it. So there is an application. This is the EB application, we call it Elastic Beanstalk. So that is nothing but a logical name given. So this is called EB app. And this EB app, we want to run in AWS. So one way of doing this is whatever we have done so far, like doing this. The other way is that you just say, I'm going to use EB app, and I need, whenever I'm going to run this application, I need some kind of environment. So I can create one environment. So this could be my dev environment. So my dev environment might be running on a single EC2 instance. But if my SLAs are pretty high, then I want to go with multi-model, or I want to go with something known as load balance model. So I'm going to have load balancer plus EC2s. So I'm going to have at least 2 EC2 instances. And this is my production environment. So app one can be deployed on one environment, which is, let's say, development environment. And then I could basically create another environment, and that I can create as a production environment. And I can say now, please run this on the production environment. And this is going to be very easy when you use Elastic Beanstalk. So when you move away from this model, so you try to use this PaaS benefits. And that is the benefit of PaaS, because it basically allows you to focus on building the application and not worry about this configurations and so on. So you can literally, do this pretty fairly quickly. And we are I think seen yesterday also how easy to set up the Elastic Beanstalk. So let's do this now once again. So I'm just going to say create a web app. So this is my application name. Let's say I'm just giving some other name. Application tags, simple application tag. What is the functionality of this application and so on? And what is the platform? So you can use this Docker, Glassfish, Go, Java, Node.js, PHP, Python, Ruby. Many platforms are supported. So I'm going to use Tomcat. And it is going to have a platform. Again, it basically has many versions of Tomcat. Tomcat 8.5, Tomcat 7. So what happens behind the scene? It is going to use the appropriate AMI. and it is going to do the same thing which we are doing manually, but Elastic Beanstalk service is going to do all those things for us. Now it is also possible that if the version which is required for you is not supported, then you can create custom AMI and use that AMI as well. So I'm just going to select the Tomcat 8.5. Then application code, you can actually upload your code. If you have a kind of WAR file, then you can just upload the file from here. You can also put it on public S3 URL. So that is something which is very handy. So that is what development team requires to do. And I'm going to just create a sample, use a sample application which is provided by AWS. And I'm just going to look at configure more options before I proceed further. Now there are many configurations. So these are all presets. So presets are generally, quite commonly used kind of models. And then Amazon is going to give you all the pre-configured settings which works for that model. So single instance is free tier. So you can basically use on-demand model also. You can use spot instances. If you want HA configuration might be required for this production environment because I want to set up load balancer plus EC2 over there. And then I'm just going to keep this single instance. Then it gives you some information about what is the instance type, what is the capacity. And if you basically want different instance, then you can come here and edit the properties and say edit. Then you will see there are additional instance types. So you have a flexibility of choosing. So that is why it is a PaaS with difference. Amazon always says that it's PaaS, platform as a service, but that is something which will allow you to still access the underlying resources. So that's one example of modifying the instance type. You can also have configure load balancer. Currently, I'm not going to use load balancer. You can configure network. So if I go to this edit, you can say, fine, now you're running this instance or creating this environment. Please use this particular network setting. So what happens behind the scene? It is going to create all the resources in appropriate VPCs which we are going to use or which we are going to configure here. So it is going to be using various subnets which we configure here. So I'm just going to keep it default. And you can also connect to database. And I'm just going to say create app. So if you look at this, kind of some event logs is shown here. Using Elastic Beanstalk AP South1 as Amazon S3 storage bucket for environment data. So it is going to create a bucket inside S3 and put all the information which is required by this Elastic Beanstalk inside that. So when you run this Elastic Beanstalk, it should have appropriate permission. And anyway, it runs in a default VPC. So we should not have any problem. It is also creating security group. It has also created Elastic IP. And it will continue further. So this will take a few minutes. Now it is saying environment has transition to pending, initialization in progress, running for 19 seconds. There are no instances. See, we are not doing anything on our own here. So this platform is doing the job for us. Let's give it a couple of minutes. Now it has created like an EC2 instance. And this EC2 instance will have this Elastic IP. So this Elastic Beanstalk tool is per se is free. And then whatever resources are launched by this Elastic Beanstalk are going to be chargeable. And if you look at this, and if I go to this particular URL, it says all thing looks okay, and I just going to go to this site. That's it. So this is something which is there inside that WAR file. So this is simple HTML page. And if you want to really modify that, you can download the code. That code is also available on AWS site. That zip file is there. And if I just go to this particular document, there is a link provided in the document. So if you look at Elastic Beanstalk section, then it will come to these tutorials, and there are a lot of examples are there. And whatever we are doing, using this in this example, it basically is using this particular file, Java Tomcat v3 zip. So you can download this and see the content which is there inside the in this particular file. So I think let me check whether I have this already on my machine or not. So I will just go to my Finder window. Okay, so I think I have downloaded this some time back. And this basically is a zip file which contains index.jsp, and it has got some additional Java files. And if I look at this index.jsp, this is nothing but a JSP page, and that is something which is showing us our content. So if I just go down, you can see, your first Elastic Beanstalk application is now running and so on. So if you want to really upload this, what you can do, if you want to change anything in this, you can update this file and zip it and upload using Elastic Beanstalk. And it is going to set this up on the Elastic Beanstalk environment again. So that is something which is called uploading the new revisions in the Elastic Beanstalk world. So this is something which is like running fine. I'm okay with it. So you are happy with your application, for example. You can upload and deploy your new versions from here. And just say deploy. That's it. You don't have to log in. You don't have to worry about PEM file, security groups. Everything is kind of configured for us. And let's say I want to change this now. So I want to, let's say, so where is my application? So I'm having another application. Okay. So sample application is here. If I want to, let's say, okay, I'm happy with this, and then I want to create one more kind of, environment. So I can create a new environment. So I will go to this environments, and I can say I create a new environment. And when we create a new environment, it basically gives you two kind of environments. We'll shortly look at worker environment also. So let's click on this. So when you actually use this Elastic Beanstalk, this is something what happens behind the scene. So it is going to create these EC2 instances, and it is going to use Elastic Load Balancer in case you have chosen that load balance mode. And it is going to run something known as one agent on that machine. and that is the way it works. So nothing special about it. Only thing it is abstracted from you. And there is one more environment which is called worker environment. Now, when you create a worker environment, what happens behind the scene? See, if you look at this particular diagram. Now, let's say you are building an application which is architected like this. So your application architecture is like this. So, this could be your web server application. Just forget about Elastic Beanstalk for the timing, but this is your architecture, application architecture. So let's say you're building this registration app. So the registration app, the request comes from the load balancer. It goes to an EC2 instance. And whenever you put any, let's say submit, then instead of putting that information in the database, you want to send a message to the SQS queue, because I want that message to be processed in particular order. And then I have another EC2 instance, which is going to be kind of reading this SQS message. And that is something which is it's your architecture. Now, if your architecture actually meets this kind of model, then you should actually look at setting up worker environment. See what happens behind the scene. It creates SQS. It is going to create these auto scaling group. It is going to create elastic load balancing. So everything is kind of comes configured with you instead of we doing that up, because we have set up SQS also. We consumed it through our CLI and so on. We basically looked at how to consume from the SDKs. So that is something which anyway you have to do from the right code perspective, but not from the setup perspective. So that is something which is the worker environment. If you are not really, if your application does not really is based on this model, then you can't really use this one. So I'm just going to select environment here. I'm going to say select. So I'm just going to say my application. Now this is my, let's say, prod. And then I'm going to say Tomcat, same thing. And sample application, but here this time I'm going to say configure more options. And I could say I want to maybe I want to run in this in VPC. So this is very configuration heavy. So if your VPC is not configured with the appropriate security group, it might actually fail. So it is a bit time consuming to set up initially, but once you understand how your networking is configured, so it is custom configuration, or I can just use high availability also. Look at this high availability option. So this is my preset. I'm just going to switch to high availability. Then if I'm going to use high availability, then what is going to happen? If you look at our load balancer over here, it says now type is 1, listener is equal to 1, process is equal to 1. And okay, so I just don't want to set up VPC. Don't want to change, let's say, VPC configuration here. And the capacity is load balancing or auto scaling. Look at this. Fleet composition on demand instances. And you are basically saying 1 to 4. So if you remember our discussion around auto scaling, if I just say edit, then we can see some values there. So you can basically look at this on demand kind of, some kind of metrics and so on. So I'm just going to select the default one. I'm just going to keep default one. And I say create environment. Now what is happening is that it is creating now a load balanced environment. So let's see what is happening. Create environment is starting. So this is my prod environment. And this will take a few minutes. So it has created a target group. Remember our understanding of this target group. So it has created target group. So whatever we have done so far using load balancer target groups, similar model will be followed by this elastic beanstalk. And if you remember our auto scaling launch configuration concept, it has created auto scaling launch configuration. So everything is happening behind the scene. And you can observe that by going into EC2. So there are no kind of instances. So I'm going to just switch. I'm going to switch to another window. Or let's say new tab. Duplicate rather. And I'm going to go to my EC2 dashboard. So if I go to my EC2, if you look at my running instances, you will see there are some naming conventions followed here. So this is my prod environment. And this is my instance. It has got public IP and so on. And it is initializing. Not only that, let's look at load balancers. And you will notice that you will have one more load balancer. Now this is created by elastic beanstalk. It is running in the default VPC. And if you go to listeners, you will see one target group over here. And the target group will be available in this section as well. So the target group is created with AWS EB name. And it has got targets. It is listening on port 80. And the target state is healthy. And if I go further to auto scaling section, so I should see the auto scaling also. If you look at the AWS EB, now you will see like two auto scaling groups here. Now whether you are using load balance or not, it is going to always use this one. And then you will also see load kind of launch configuration associated with each group. So if you look at the activity, you will see activities, you will see all the instances and so on. And once everything is set up, and if I go back to my elastic load balancer, I will see that this will be time consuming. Obviously, it is going to take time, and it has transitioned from pending to OK. Looks good. So I'm going to go to this particular one. So the same application, but this is another prod environment, but behind the scene, it is all auto scaling and everything is set up for you. It's running behind the load balancer. So that is what the benefit of this elastic load balancer is, and the elastic beanstalk service. So you can go look up the configuration. So you can also look at the AMIs. So this is the AMI, which is kind of there. Then you will see some capacity setting. Now this basically capacity set. If you look at, it's very parameter heavy. So I think it is based on network out. So this is not purely on the CPU capacity, but amount of network transfer which is happening. Based on that, it is going to decide whether it will actually scale up or scale down. And this is the load balancer configuration and so on. So if you terminate any of the instances, or if there is a health check issue, then this environment is going to automatically keep your instances running. So that is the way this elastic beanstalk works. So if you go back to your picture, so this is again built on top of the existing AWS services. So this is called elastic beanstalk, and then it is going to use many services. So one is EC2, second is ELB, third is auto scaling, and whatever is related to launch configuration and so on. So this is your kind of typical when a deployment happens in AWS. So this could be your one of the approach of deploying the application. So for any questions on this elastic beanstalk? So are you using elastic beanstalk in your environment, in your solution? Anyone using it? Anyone planning to use it? All right. So I think let's proceed further. So it has got many features. You can also do various updates, rolling updates. So let's look at those. Okay. So we just saw how to use this elastic beanstalk. We can still access underlying EC2 instances. So what do you do in the elastic beanstalk? You create an application, upload a version, launch environment, and then you just monitor the kind of environment. Don't have to really do much. So typically you develop your application locally, test locally, and then deploy using AWS Elastic Beanstalk. And that is why in the AWS toolkit for Eclipse also, you see the Elastic Beanstalk is actually shown in the Explorer, Tool Explorer. I think we have seen this application is nothing but a logical collection of components, including environments, versions, environment configurations. So I think that is, we have just seen that. So I can use the application and create multiple versions. So if I go back to my here and I upload and deploy, then I can give a version label over here. So I can just say version 2 here, and it will be deployed. And what you can do, basically, you can then you can say that I want to now deploy earlier version. So that is called rolling back. So that is also possible. And you will see that the deployment preferences something is there. So depending on the number of instances which you are having, you can also decide what is my deployment preferences, what is my deployment policies there. Okay, then environment configuration we have seen. So web tier versus worker tier. So again, it is just a convenience mechanism. It is not something which you have to use, but it makes life much easier, especially for those guys who are not really familiar with AWS. They don't have time to actually investigate how to configure and so on. I think we have looked at some sample configurations also. So we have configured load balancer. Said I want to use VPC. So that is something which you can set. This is also we have seen. So this is what happens behind the scene, and you can basically have a database. Now, when you work with database, we generally launch database. We generally don't launch database using Elastic Beanstalk. So we basically have the provision, and then you can just connect to that particular database server. So it allows you to pass some environment variables also. So you can pass environment variables to this underlying nodes. That is also possible with Elastic Beanstalk. HM stands for host manager. So it gives you instance events. So if the application is down, then it is going to monitor the application log files. If it has to do patching, it is going to do the patching. It is going to perform patching and so on. So let's look at deployment policies. I'll just look at this. I think you must be familiar with this model. So what do you use for deployment at John Deere? What are the tools which you use? Anyone? Which tools do you use for deployment or deploying applications, or is it you have some different teams who are doing deployment for you?
No, basically we have Jenkins and Drone.
Okay.
Scripts which internally gets executed using CloudFormation or Terraform.
Okay. And you write CloudFormation scripts or somebody else writes those?
We write it.
Okay. All right. So anyone who is new to CloudFormation? Anybody has not heard or used CloudFormation before? Okay, it looks like everyone is familiar with CloudFormation. So Elastic Beanstalk behind the scene uses CloudFormation. So everything is going to be kind of done using CloudFormation templates, CloudFormation, and that's what happens behind the scene.
Yeah,
all right. So yeah.
Amod, I think if you explain the CloudFormation, then it will be good because we are not aware. I think few of members are.
Okay.
Yeah, Amod here.
Yeah, Amol, okay. Who is not aware of CloudFormation? Anybody else? It's okay not to know. It's fine because we are here to actually understand. Because even I haven't heard about many things or many tools. Every day I come to know that something is new. So we will cover CloudFormation as well as a separate topic. So CloudFormation is nothing but it's something like a template which you basically create using a JSON file or YML file. We will take examples of those as well. But that is what happens behind the scene. Then there is something known as rolling deployment. So rolling deployment is nothing but, let's say you have application running behind the load balancer and your user is going to access the application. So now the user is directed to any of the instances depending on how the requests are routed. But when you use application load balancer, it's a round robin algorithm. So one request will be sent over here. Next request will be sent to another instance. Let's say I want to do patching. So if you want to do patching, then what you should do, if you have two nodes, then you can take one offline. You take that one offline and do the patching over there. And in that case, also the user traffic is not affected because the other instance is serving the traffic. Once it is done, it is successfully done, then you what do? You put that back in service and take the other down. And then you do this on other node. And if it is successful, then you put that node as well into the pool, or we'll put it behind the load balancer again. Now this is called rolling deployment. Now if you want to do this manually, then you have to really synchronize, which instance to go down and so on. But just remember that Elastic Beanstalk provides the facility. If you are having more than one instances, you can choose what is my deployment policy. So you can say do rolling deployment. So automatically it is going to do the rolling deployment. So it might take one instance out and another instance will be serving the request and so on. So that is something which is possible using Elastic Beanstalk. There are a lot many features. We cannot really try in each and every feature. So we have to just understand the core concept and then understand the features and understand what is the feature and what is the benefit of the feature. And then whenever you have a requirement, you can always explore, look up the AWS documentation and find out the related steps. You can also do something known as blue-green deployment. So blue-green deployment is what? It's a deployment model. So there are the various deployment models or method deployment policies. So when you use blue-green, then your deployment time really increases. So what is blue-green? So let's say, let's assume that you have an application running and that is managed using Elastic Beanstalk. So assume that there is a one instance only. It's running behind the load balancer. And there is one EC2. So when you are going to go for blue-green deployment, what is going to happen? Behind the scene, it is going to, let's say, create one more node. Have we lost?
No, we can.
Hello, can you hear me?
Yes, I can hear you.
Yeah, I think there was a glitch somewhere. Are you able to see my screen or not?
Yes, I was able to see the paint screen where you are going to draw the EC2 instance with a green color.
Okay, no, that is good. Okay, so I'm just going to stop and reshare. Okay, can you see this now? Board by whiteboard.
Not yet. Now I can see.
What about others?
It was there, but now it's a screen. Now I'm able to see.
Okay. So when you actually talk about blue-green deployment, then what happens behind the scene? The additional instances are created, and so it is going to create a new instance, set of application over here. That is going to happen behind the scene for us. So it requires additional set of instances. So if your application requires multiple instances, let's say it is running on, let's say bigger size instances and so on, and different applications, then it might be a bit challenging to actually use blue-green deployment, because the cost of the blue-green deployment is pretty high, because it is going to create additional environments, additional machines. So if you have two machines over, it will actually create two machines over there. But depending on your requirement, you can actually choose what is the deployment policy. I think has to be dependent on the SLA. So if there is no downtime required, then you can think about having and if there is okay downtime, small amount of downtime, then you can think about doing that on the same instance as well. But generally, what people do is that for major releases, they will spin up new EC2 instances and set up that, upgrade fresh, and directly put a new release over there and take down the earlier instance. But Elastic Beanstalk will actually make life much easier when you use these various policies. So depending on your requirement, you have to really use this appropriately, and you can really monitor your environment. So if you look at my healthiest count, target response time, CPU utilization, you get a lot of information about this. It is much easier to manage using Elastic. And once this is like done, then you should terminate your instances. If you want to really try some certain things, you can keep it running. Because if you don't terminate, and if you terminate from EC2 instances console, then what is going to happen? There is an auto-scaling element which is already configured. So that auto-scaling is going to always spin up new instances just to maintain that minimum number of capacity. So I'm just going to, you can also restart app servers and so on. I'm going to terminate my environment. So everything will be destroyed. So there is no need to really go and clean up individual environment. I'm just going to say terminate. So this basically, it's very quick. So if you want to just create new environments, test it. If you want to share it with customer, you just upload it to the Elastic Beanstalk and share the URL. It's much more kind of simpler. All right, so that's about Elastic Beanstalk, and Elastic Beanstalk can be used to even deploy containers and so on. So we will actually move on further with another topic, which is called ECS. Now we have seen the containers and Docker. Now everybody is not familiar with Docker, I understand, but some of you are already using Docker, maybe in your own understanding purpose, for your own understanding purpose, or some might be using in the projects. Now let's understand what is this Elastic Container Service as a concept first, and then we'll go into the details. So we saw how to actually, when you look at Docker containers, so we saw how to install Docker. So we did that sudo yum install Docker. Then what we did, we said that, okay, I want to run this specific container. So I downloaded an image. So I said Docker run specific image name. And then I'm running that on EC2. So that model is simple for single instance. But we are going to look at something known as Elastic Container Service, or in short, which is called ECS. Now it is used for the container kind of workload, container orchestration, and so on. So if you are familiar with Kubernetes, then this is similar kind of thing. And what it does behind the scene, it is going to leverage all the things which we have seen so far. So in the ECS concept, what happens? There is a concept of cluster. Okay. Now there is a concept of cluster because the cluster can contain multiple nodes. So it can contain, let's say, EC2 1, then it has got EC2, EC3. So there are multiple instances. They're all EC2 instances. And then these instances are a part of this cluster. Now, why we are basically looking at ECS? Now, for single instance application, that's fine. But when you are actually having multiple applications running as a container, and there could be multiple applications. So generally, there will be different kind of microservices. So you might have simply, if you take an example of our registration application, it has got registration. So you will have some code which is written to actually insert it into database. There might be some code which is, sending the message to the queue. Some code might be actually sending an email to the kind of registered user and so on. So in that case, you are typically have multi-container applications. So you have multiple containers running. And then how do you ensure that those containers are running and so on? So in our case, we are running our Docker container on EC2 right now. But let's say your EC2 instance gets stopped. Okay, so EC2 instance got terminated somehow. So if I go back to my EC2 dashboard, and if I just stop the instance, my application will be down because instance is down. Now that is something which may not be desirable for many applications. So if I just stop my instance, my application is going to obviously stop. So I can just go and stop or terminate. But if that happens, that is going to be not something which is good for the application point of view, because business functionality requires that should be up and running. So how do you ensure that it is up and running? So in that case, what you can do, you can deploy your application inside ECS cluster. And this works with containers. So we have seen our regap container or even HTTPD container is also there. So if I'm going to say HTTPD container, just put it over ECS. And then I'm going to say, please run at least one container instance. Then what is going to happen? This ECS is going to ensure that one HTTPD is running on any of the available EC2 nodes. So it might happen that this HTTPD will run over here. So let's say HTTPD is running over here. But after some time, what happened? Because of some reasons, this instance got terminated. Now, because we are using ECS and the way we are going to configure ECS using something known as a service concept. In ECS, there is a concept of service. We are going to say, please run at least one container. So ECS is going to figure out that one EC2 instance has gone down. There is no HTTPD running. So it is going to spin up HTTPD container on other available instances. So what is going to happen? This HTTPD is anyway get dead. So it is going to spin up new HTTPD container or a Docker container over here. And this is going to be running over here. After some time, this also goes away. Then this HTTP will be running over here. And that is what is the benefit of this whole ECS model is. So it will always ensure that desired number of instances, when I say instance, a desired number of containers, Docker containers are running on my cluster. So from end user perspective, there is an end user, and from end user perspective, let's say they are going to use your application. For them, they are going to just use this particular endpoint. So there will be some endpoint, but that endpoint internally using HTTP currently which is running. But if this goes down, internally it is going to strap to another instance. So your end user is not affected. So that is what this model is, and that is something which we are going to look into it further. So have you understood kind of need of ECS. Why ECS is typically used. So this is a container management kind of platform. It's also called container orchestration. So because when you are working with single kind of in a container, then it is fine. But typically when you are having multiple containers, so what is a classic example? So classic example is, let's say you have a application tier. So just for argument's sake, let's say there is a web container, there's an app container, and this app container gives some services to web and so on. And let's say there is a DB container. So I have 3 Docker containers running. So what is happening? Web will actually use app and app will use DB. Now when these 3 containers are running, now we have to ensure that web always runs, and I have to say web should actually have 4 containers, or there should be 4 replicas of this web container. I should have 4, and I should always have 1 DB container. So this is my model, because from the scaling perspective, from availability perspective, I somehow figured out this is something which I required minimum. Now, that is something which you can, if you want to manage this individually. So what is going to happen? Let's say that you want to use ECS, and you want to leverage our EC2. So in that case, if I'm going with an EC2 model, so what is going to happen? You will create, let's say, 4 EC2s. That is something which you are going to do this manually. So 1, then 3rd, and 4. That is point number 1. Secondly, you will also want to put this web, so you will run on each machine. You will have web. This you will have web. This will also have web. This will also have web. Similarly, you will put app on the same set. So you will have app also here, app also here, app also here, app also here. And DB is running on one of the instances. Let's say, assume that DB is running over here. If you just don't use this ECS model, then in case any of the node goes down or the container goes down, how are you going to manage it? There has to be some kind of orchestration where somebody is really monitoring what is the container state. If it is stopped, ensure it is going to start one more. And it always ensures that this set is always running, so as to make application highly available as well as scalable. So without ECS, it is going to be very, very difficult to manage, because you have to really set up many things. So if all the nodes are gone for a toss, then what? Then somebody has to really spin up all the EC2 instances, set up Docker containers, set up Docker engine, and set up all the Docker containers and so on. Even if you introduce automation, it is a bit cumbersome. So instead of doing this on your own, or building your own custom solution to manage this, now you can use ECS. So this is going to again rely on additional services, or rather existing services which you have seen. So this again internally relies on EC2, load balancer, auto scaling, launch configuration, and so on, and all the things which are IAM, then IAM role. So whatever we have seen in VPC, IAM, then S3 also, if you want to use, you can use EFS, which is used for storing the data, which is kind of the container wants to store some data, it can use EFS. So all these things you need to be very, very clear when you want to use ECS. Otherwise, you will not understand what is going on behind the scene, how it is really working. Any questions on ECS? Anything? Anybody using Kubernetes here? Anyone on Kubernetes platform? So I think it looks like people are not using Kubernetes. Anybody has used Docker Swarm? All right. So in order to use ECS, you have to understand containers. If you don't understand the containers and Docker, then it is not going to make a lot of sense. And that is why we discuss briefly about Docker containers. What is the concept of Docker and how it addresses the issues in deployment, and it enables this build, ship, and run methodology. So somebody is going to build the image, and that is available through Docker Hub as well as through Amazon's its own container registry, which is called ECR. So just quick recap, container is nothing but a runtime instance of an image. It contains all the software you need from OS, application, configuration files. And Docker is one type of container. See, nowadays Docker is synonymous with container, but there exist other types of containers as well. And this container technology is something which is not new to Linux world. So it internally uses, namespaces and so on. So container has been in Linux world for a while. The only thing which made Docker, what made Docker popular is that Docker is very easy to use, and Docker made this container popular. Images based from which containers are instantiated. Image is static, it's compile time, it is read only. And finally, we have registry, which is nothing but the storage location for images. And Elastic Container Service, as we have just discussed, it's a highly scalable, fast, easy to use container management service. Now remember, this is an Amazon product. So Amazon is trying hard to actually sell this. And in fact, Amazon never thought they will actually have to give support for Kubernetes. Now we know that the Kubernetes is from Google, and now it is available into open source, I think. So Amazon never wanted to actually provide Kubernetes support, but there exists another service in AWS world which is called Elastic Kubernetes Service. That is also used for the same purpose. The reason for Kubernetes is so popular is that even in spite that is been comparatively hard to set up on the on-premise environment. The benefit of Kubernetes is that you can really set up Kubernetes in your on-premise environment. You can set it up on Azure, you can set it up on local machine, you can set it up on on-premise data center in an office. And the same thing can be really smoothly running in all the environments. But in case of Amazon ECS, you cannot really deploy and download it on your local instances. So when you work with ECS, you have to always work with AWS. And as AWS, you have to really log into AWS console or AWS account and use it. It's a centralized service to run, stop, and manage containers on top of the cluster of EC2 instances. See, it needs EC2 instances. Now, this is something which is legacy, and now we will talk about something which is one more kind of category, which is called launch time, which is called Fargate. In that case, you don't have to really manage any EC2 instances. Then it also enables you to schedule the placement of containers across your cluster based on resource needs, isolation policies, and availability requirements. If I go back to this particular my board, and let's say you want to deploy this web application app and database. Now, which will require more size in general, in whatever scene, what is the kind of, it requires much more memory and CPU. What's your experience? Is anybody using database with 2 GB RAM when you are going for the production environment? So generally, you know, databases are very heavy. So if you are running any application, production grade application, yes, please.
I was saying DB, I think, because application and webs are like generally not taking that much
Yeah,
memory.
that's correct. Yeah, that is correct. You know, now this is not something which is true for all the cases, but yes, in general, it is true. I think we can say apply 80-20. And 80, even in fact, more than 80% of the cases, you will always find this database is very heavy in terms of configuration. So when you talk about web server configuration, yeah, you generally work with 2 CPUs, 4 GB RAM, 4 CPUs, 8 GB RAM, something of that configuration. And database servers are pretty heavy. So most of the production grade deployment, if you are really working with enterprise grade, then they will have at least 64 GB of RAM and maybe 16 core or something like that, because database is like memory hungry. So you want to throw as much as memory, it will take as much as memory, especially SQL Server. So why I'm basically bringing this point is because whenever this cluster needs to actually schedule some container, then who is the best resource? That is something also decided. So you might have multiple EC2 instances, but there will be some EC2 instances of bigger size. So you want to have an EC2 instance with, let's say, 16 CPUs, vCPUs, and 64 GB of RAM. Now you might decide that I want to run at least 2 EC2 nodes with this configuration. And whenever this ECS should actually use this database, so database should be actually deployed only on these. The reason being, because those are kind of designed or optimally used or chosen so as to run my database container. So even if my cluster is having 3, 4, 5, 6, I want to have some kind of an affinity towards specific resources. So this is also called, you know, some kind of constraint-based decision. So you can put some constraints. Put this DB on this EC2. Now all those constraints are specified in some specific file, which is called typically in the Docker world. What is it called? Docker service.yml. So in that you specify all those kind of constraints and so on. So that is what the job of a kind of ECS. So there are a lot of features, and in fact, if you want to really understand or utilize lot many features of cluster, then you have to go back to Docker and understand Docker features first, because behind the scene, it still uses Docker heavily. So I'll just go back to my slide. So depending on your resource needs, isolation policies and availability requirement and so on. So isolation policy meaning, like, you know, we have not touched upon something as Docker contain, Docker network, but you can really design your application so as to create kind of networks. So you can say, okay, I want to run only this particular container in the app container. Now remember that we have also created a VPC, and if I go back to particular this picture of our VPC model, then our VPC is nothing but a networking model. But this is something which is happening at the AWS level, AWS VPC. But even container also provides you a container networking feature. So that is on top of this, the underlying network. So that is a separate network altogether. So what we can do is that we can basically go inside this Docker file, that configuration files, and you can say that I want to basically keep all these web servers in one network. When I say one network, this is from the networking point of view. This is the Docker network, by the way. This is not our VPC network. So this is going to be one network. And my, let's say, another network is especially database I want to keep in different network. So what I will do using this Docker kind of configurations, I can create another network. So this is my Docker network. and then you have to basically allow which traffic flows from one network to another. So again, that is very configuration based. So we are talking about many concepts here. And when you want to really understand ECS, as I said earlier, you have to really correlate all these things, how it basically working together. You have to really start visualizing it, because it's a bit kind of involved in terms of understanding this, how it works behind the scene. As a concept, it's fine, but you have to really debug it. That is going to be a bit nightmare. So again, you can basically use ETL, sophisticated application architectures or microservices model and so on. This is a regional service that runs the containers in multiple AZs for high availability. And these ECS clusters can be created within new or existing VPC. Container images can be pulled from container registry, which may exist in Amazon ECR or outside of AWS, Docker, or self-hosted also. So that is the concept of ECS and the benefits of it. So obvious benefit is eliminates the need to operate own cluster management configuration and management system. And the best part is it is free. But understand that free does not mean that it is completely free. It is free. ECS service is free, but you're paying for EC2 instances. You're going to pay for EBS volumes. So that is not free. So all the resources which are launched by our cluster will be chargeable. So ECS architecture, I think let's look at this diagram. So what happens when you start using this? Let me actually go to this particular, but that picture will not have this particular diagram. Okay, so what you do, you set up ECS cluster and you have container images. It could be loaded from ECR, it could be GitHub, not GitHub, sorry, the Docker Hub. And the container instances, like EC2 instances, are running over here. And then this cluster, so this is the cluster. So first step is cluster. And then each container, you have to create something known as task definition. So again, it introduces its own vocabulary. So task definition is basically the container definition, which container I want to run. What should be the memory I should allocate? What is the hard limit on the memory which can be used by container? So all those configuration can be defined using task definition. And when ECS runs our task definition, it's going to run as a task on the available EC2 instances. And we'll understand what the service is. Now there is one more kind of launch type, which is called Fargate. Fargate is again becoming more popular. Now specify the task definition, and in this case, it is going to run your container somewhere far. You don't know it is running, but basically it is running inside your account. But the major difference is this: you don't have to really manage EC2 instance. There is no EC2 instance which you will see. So it is going to run somewhere. So similar to your Lambda. Now we have seen Lambda, when we actually execute our function, so Lambda runs as a container, but it runs where? So if I'm correct, then internally I think Lambda also uses this particular technology, and they have tested this, and then finally they made it available with as a Fargate. So in this case, the benefit is that you don't have to really manage any EC2 nodes, and you will always get something known as elastic network interfaces. Just a brief about this elastic network interface. Network interface is going to give an IP address. Those who want to really go into nitty-gritties of this, so what happens behind the scene? So whenever we spin up an EC2 instance, whenever you are using an EC2 instance, we say that EC2 instance is having an IP address. But if you want to be very precise, then what happens behind the scene when you spin up an EC2 instance, it gets an elastic network interface. And this network interface gets an IP address. So this is very precise. So EC2 does not have an IP address, but this is the elastic network interface. So what you can do in principle, Like if you are having another EC2 instance, I can, if this EC2 instance is kind of gone, then most of the time the elastic network interface is also deleted. But if I want to, let's say this instance is having a specific IP address, let's say 10.0. Let's say 2.4, and somehow some of the applications are actually specifically using this IP address, and somehow this IP address cannot be changed, and if instance has gone for a toss, then what you can do, you can basically attach this ENI to this EC2 instance, and this will get 10.0.2.4 as an IP address. So this, even if this is not there, then your other application will not be affected. So this is what happens behind the scene. So again, as you go deeper, there are many such elements, and that is something which ENI will be provided. And when the Fargate is going to run your Docker container, depending on your configuration, and it is going to give a public IP. So it might give public IP something like 15.14.20. Something, and your application will be available on this particular IP address. So this is what Fargate uses behind the scene. We don't have to understand how it works behind the scene in detail. So that's another benefit of using Fargate. You don't have to really spin up instances. So ECR is a AWS hosted unique repository for Docker images. Now, if you go with Docker Hub with public repository, then it is publicly available. So obviously, when you work in an organization, you will have its own private repositories. If you're using AWS, you can use ECR. Again, it is having some charges. It is not completely free. A task definition. So what do? You create a task definition. You specify images to use, repository to use. So we have seen our Docker container. If you want to use the Docker container, so you have to specify the Docker image. Like whatever Docker image I'm using, that Amod, Kadam, CM, register app, whatever it is. Then which ports you want to make it open. So in short, what it does, if I just go back to our Docker kind of a thing. So set up Docker, yeah. So all the things, you set up Docker and everything will be done by the CCS for us. So it is going to use some pre-built images which has Docker running, and then when you run your task definition, in turn, basically it is going to execute such kind of commands depending on your configuration. So this is very simplified kind of an explanation of that. So instead of you doing it, let ECS do it for you. Then you have task definition. This is an example of a task definition. So if you want to run, let's say, in Nginx, there is another popular web container. What we are saying, so we have to create task definition, and you say that this task definition contains a family as web server, and then container definitions name is web. So this is nothing but the Docker name which you give to the image name, CPU, how much CPU you want to allocate, memory, how much memory, and then port mapping. So when you work with the Docker container, there is always a container port on which it is listening, and there is a host port. Host port means how much on which IP address, sorry, on which port I want to, on which port I want to expose this container. So we have seen our Docker containers. I was accessing our Tomcat-based application port 8080, similar to that. Task is runtime instance. I think that we have seen. Then whenever the task has to be scheduled, so you specify the task. So as a developer, as a programmer, your job is to just specify the task definition and service description. So from a developer perspective, it is not much here, but it is a primarily deployment service. And then ECS is going to schedule this, and it is going to do a placement of tasks. So again, there are various placement algorithms. It is going to place our task on available instances inside the cluster. Services, finally, it maintains the desired number of tasks running. This is called service. So I want to have like 4 web containers. So as I was talking about here, so I have to define this as a service. So this is something which I have to configure using service element in ECS. Then the service is going to use as logical kind of grouping, and ECS will try to maintain as many instances as possible. Then cluster is nothing but a group of EC2 instances or Fargate type. Now this is a new one, and you have to define what is the instance type if you're using EC2 instance, EBS, key pair, VPC, role security. But in case of Fargate, you have to just specify how much CPU and memory is kind of needs to be provided, and accordingly, Fargate is going to do all the plumbing work behind the scene. All right. Any questions so far? All right. So as a next step, let's go to login to our console, or just go to console again and just see this in action. So I go to ECS. Yes, any question?
Hi, Amol here. Actually, I can't see anything. Are you sharing something?
What about other guys? I am inside my AWS console.
Okay. Can see. So it can.
You can see.
I'm still seeing the your that PPT docs. ECS decorated.
No, I am basically on this people participants screen. So Mukul, are you able to see this?
Now I can see your Teams, Microsoft Teams.
Correct. Yeah.
Yes.
Yeah. Okay. All right. So I will just log into. I'm just switching to console. So remember to do this cleanup. Otherwise, we will have a lot of instances running. All right. So this is something which is again specified inside the compute category. Yes,
Sorry,
please.
I can still see your Microsoft Teams.
What about other guys?
You are able to see your AWS screen now.
Okay. I
Okay,
think
then
there is some delay from your end, so you can just re-log in.
Yeah, sure.
So we are at the mercy of the internet and the speed. Okay, so I just want to create a cluster. So I have decided to use ECS. So this ECS is available under. It used to be available under computer earlier, but I think they have created a separate category altogether. Look at this, and this categorization do change a lot because they are adding so many services. So I'm just going to use Elastic Container Registry here, not container registry. I'm just going to use ECS Elastic Container Service. Now, in your case, you may not have any clusters. So this is the first step. So what we do, we create a cluster. So let's create a cluster. Step one is create cluster. And this is going to decide what is our launch type, whether I want to use EC2 and so on. Since we are familiar with EC2, let's go and set up a cluster with EC2. So I'm just going to create cluster and then use this cluster template. So this is kind of one-shot template configuration. You don't have to really do much here. You have to just select. So it is powered by AWS Fargate. So that is something which is preferred. The other one is called EC2 Linux plus networking. Now this is networking only because there is no EC2 here for us. And this is EC2 Linux plus networking. It is going to create VPC. Again, here VPC is optional, subnets optional. But here VPC subnets you can configure. And it is going to use auto scaling group with Linux AMI. And if you are using Windows, then Windows is also supported. So generally speaking, many of the features actually are first of all tested on Linux, and then the support comes to Windows later. I'm going to use EC2 Linux plus networking. So if you're just going to follow this, just select this one. And I say next step. Now, whenever we are creating the cluster, we have to configure a cluster. So when a cluster means a set of nodes, so that cluster can be, so for end user, it is just a single endpoint. And I'm going to say Amod, Kadam, JD. Today is 28th cluster. And what is the provisioning model? So whether you want to use spot instance or on-demand instance. Now, depending on your business load, depending on how you want to run it, now, spot might be actually useful model as well here, because spot will give you a lot of flexibility in terms of cost, 90% discount. But let's keep on demand for the timing, and ensure if you are doing this, don't use M5D large. It is very expensive. So you choose a T2 micro. So I say T2 micro or T3 micro. I generally use nowadays T3 micro. And then how many instances you want to run? Now you can literally run like 10, 100, depending on your account settings. But I'm just going to run one. And then if you look at the AMI ID, so I'm just going to use the Linux 2 AMI. So you can't really use any different AMIs. There are some specific AMIs which you have to use. And what is the EBS volume? 30 GB is pretty high. We can keep it 8 GB also. We can go with lesser size. Key pair. Well, I want to connect to this instance in case I want to debug anything. Then I can just select my key pair. Networking, you can really choose to create a new VPC or you can use the existing VPC. So I'm just going to use the default VPC in this case. So default VPC. And I'm going to select subnet. And I'm going to select my public subnet in my default VPC. So I will scroll down, public subnet, public, okay, public subnet looks like, okay, public subnet 1A. So what is going to happen when the cluster is going to set up, it is going to spin up those EC2 instances in this subnet. Do I want to assign public IP? Yes, enabled. Security group? Yes, I want to create a new security group, create a new one. Now, generally for demonstration purpose, I always create a new, but in practice, you can reuse the existing one also. And this is my port. So you can also give all the ports. You can keep all the ports open. You can keep port 80 open. Same as security groups for EC2. It's nothing but the EC2 security group. And then you have to specify IAM role. So what happens that there is something known as ECS container agent that is going to run on each of those AMI or those instances. And this allows you to make calls to Amazon ECS API. So that is something which is required to understand IAM role concept. And then that's it. So you have to just say create. So I'm verifying my setting. Ensure that you select T3 micro, T2 micro.
Hello, Amod.
Yes, please.
Amod, can you explain the IAM role again?
Yeah.
Or we should use the existing one?
Yeah. So basically, this is. Do you want to understand? Should I repeat the IAM role concept as such, or only for this one?
Only IAM role means actually you have that ECS instance role, and I do have three options: create new role and another two which we have already created. So
no. So okay. So are you getting ECS instance role over there?
yes.
Yeah, just select that role, because what happens? There is a container agent which runs on the EC2 instance, and it is going to make calls. Yes, please. Your voice is
sorry.
cracking.
Yeah, sorry to interrupt you. So ECS instance role is one by default, or you have created previously?
No, I think when you create a cluster, if you do not have the ECS instance, we can create one for you. It can create.
Okay, so I will create a new role only.
No. I think this whole setup should create it for you.
Okay, so because I am able to see two, like one is the elastic beanstalk EC2 role, which training
You don't.
role, and
You don't see any ECS instance role.
no, I don't see.
So what options do you get here?
I am getting create new role, then in AWS hyphen elastic beanstalk.
Okay, then you say create new role.
Okay, fine. Okay, thank you.
Yeah. So this is something which is required so as to allow this ECS to invoke some API actions, and then I just say create. Okay. Fine. I think it will take some time. It takes like, now it is very simple cluster, so it should be done in like couple of less than a minute, I would say. So what is happening? It is setting up ECS cluster. It has set up IAM policy. It has successfully attached that. Look at this CloudFormation stack here. It is using CloudFormation to create the underlying resources. It's done. And this is what it has created for us. T3 micro, desired number of instances, 1. Whenever you say desired, you should always flag that it is basically auto-scaling configuration. So it has used key pair, AMID, this is my VPC, this is my subnet, and this is availability zones which are there in the sub kind of, in my VPC, security group, launch configuration, auto-scaling configuration. So again, all things are actually brought together in this particular model. And view cluster. All right. So those who are trying it, I think let's wait for some time, and I think we will take a short break now, and then we will resume in another 15-20 minutes. So let's start session at 16:20.
Okay.
Right. Yeah. So I'm just stepping out for some time, but I'm sharing my. Sorry, there's a message. I think let's start in a couple of minutes. Yeah, I think shall we begin?
Yes.
All right, so I think let's proceed further. So is my screen visible?
Yep.
Yep.
All right. So what we have done so far in the context of ECS, we have created a cluster. And this is the cluster ARN. Then status is active. And it is in registered container instances. So just be careful about the vocabulary here, because there might be some confusion. But when I say container instances, in the context of ECS, it is going to refer to EC2. And behind the scene, it has created an auto-scaling group. And you can see those instances by going to ECS instances tab. Okay. So this is our instance, container instance. So there are various identifier. One is called EC2 instance ID, that is nothing but instance ID. Status is active. Agent connection is true. Running tasks, no tasks are running. And it is giving you some memory information, CPU available, memory available, and so on, Docker version. So what is happening that on that AMI, that the AMI which is used by this cluster to launch EC2 instances, the Docker is already set up. So our job is to just run tasks. So for that, what we do is we use something known as tasks. So for that, we can, I can say just run new task. So I'm going inside task and say run new task. And you come to another screen where you say select the cluster to run your task definition and the number of copies of the task you want to run. So we are going to use launch type with EC2. And then I'm going to use the task definition. So there is basically, do you see any application there, console sample app? Anyone trying that out?
Yes, I'm not getting anything. I think it's in a family, it's a null region. Nothing.
Anybody else? Do you see any values there or not? If not, you can enter some.
No, I'm refreshing my screen. Let's see whether I'm getting or not.
Yeah, just try that. Let me see. What are you getting? Are you getting anything or no?
Actually, I'm not getting anything.
Okay, so let's do one thing. So in that particular document, there is on page 26, you will see lab using Amazon ECS. And you should go to this particular link. So let's proceed using. So did you manage to go to that link?
Yes.
Okay. Good. So what we are going to do, we'll set up we create a task definition using that. So this is a task definition. So what we are going to understand is what is it? So it basically contains it's basically nothing but a Docker kind of all commands, all kind of parameters are there. So let's copy this. So it is going to provide container definitions. So what we need to check is that what is the image name? So if you look at this image name will actually is coming from the Docker Hub. So by default, it is going to Docker Hub. And if you go to Docker Hub, you will find this image also. And some memory constraints. And in that, it is going to run one command. There is one entry point. Now this is very Docker specific. So when the Docker container runs, it is going to run this command. And this is bin sh -c echo. So this is going to echo some file. It is going to create this HTML file. And then it is going to map this port. So it is going to use container port is 80 and host port is 80. So it is going to be exposed on port 80 on the host. I'm just going to copy this. And let's go to one cluster and I will just switch back to my cluster. Okay, you will see on the left hand side there is a task definitions. Just click on task definitions.
Okay.
And yeah, are you able to get task definitions?
Yes, yes.
Let's say create new task definition.
Okay.
And in this case, select the launch type compatibility. We are going to select EC2.
Okay.
Click on next step.
Okay.
And then give the task definition. You can give any name. So let me give Amod, let's say JD, demo task definition. So typically this will be having some kind of application name. You can just say this is the task definition for this application or this container. Select role. So you can select role ECS task execution role. And the network mode is default. Just keep default. Are you getting this?
Yes, actually, not getting anything. It's none.
Task role.
Means I'm not getting anything in task role. It's I'm just getting none as an option.
Okay, then you might have to create a task role.
Okay, fine.
And the network mode is default. And then task execution role is IAM, ECS task execution role.
Yes. Okay.
So it can create. So just keep everything default. So let me restart because it's very configuration heavy. If something goes wrong, it is not going to work. One second, just a minute. So let me create this new task definition. EC2. This is the next step. I'm just going to keep everything default. I'm also going to say task definition Amod, JD, demo, ECS. Okay, it is an optional IAM role. That's fine. Just keep it. Let's see whether it works or not. Network mode is default. So let's keep only all the mandatory things. And then if you scroll down, just scroll down, you will see configure via JSON. Do you see this?
Yes. Yes.
Yeah, just configure via JSON and copy paste the kind of code from which is there on that link. So whatever the definition is there, is going to copy this and paste it and click on save. So instead of doing this manually from the container definition, that is much more easier, convenient. And let's say I create.
Okay. Just.
So it is saying created a task definition successfully. Are you getting this? So I have not chosen any role here. I just kept everything default.
Mm-hmm.
So I just created this task definition is created. Now this task definition is created, but our task is not running yet. So step 2 is create task definition. So after creating cluster, then step 2 is create task definition. So task definition contains which container I want to run and so on. So next step is what? So if I just go back to this documentation. So we created the cluster, that is already done. And the next step, we are going to create a service. Okay. So the service allows you to run and maintain a specified number of instances of task definition simultaneously in Amazon ECS cluster. So in this case, the third step is create service. Now, service basically gives the logical grouping and it allows you to say that I want so many tasks running. Task is nothing but equivalent to each Docker container instance. So let's create that. So let's go back to cluster. So that's fine. This is done. And where do we see services now? Okay. So if I look at my clusters, I may have some additional clusters, but this is something which I created just now. I'll go inside this. And if you look at this services, you see create. Do you see service tab here? And you see create service. And you configure a service. So here you specify what is the task definition which you want to use. So I'm going to say, what is my launch type? I say launch type EC2. And then if I look at my task definition, so I don't see mine which I added. So I have to copy the task definition from maybe, and then so I will refresh this screen. Let's see whether it refreshes or not. Are you able to see your task definition there? Okay, so let me open another window. So let's hit tab, duplicate. So in my task definition, let me see what is my task definition name. I will try to copy paste there. Well, let's see whether it works or not. Okay. Okay, so let me choose the existing one. I think if you are able to see yours, then you can actually use that one. Not sure what happened. Are you able to see any task definition in your service list? So I'm going to use my existing one, which is already there. So I will just use okay. So I'm just going to create service. So EC2. And I'm going to use this console sample app static. So if you can see your latest one, the one which you created just now, you can use that as well. And this is my cluster. And this is something which I'm going to say service name is going to be my Amod JD service. Then it is saying replica services place and maintain desired number of tasks across the cluster. Daemon service places and maintains one copy of your task on each container instance. So depending on your service which you want to set it up, you can do that. So if you want to really set one kind of web server on each node, then you can use the daemon. And in this case, I'm going to say number of tasks equal to 1. And I just keep everything default and click on next steps. And again, it is asking whether you want to configure network. So I'm just going to go with the simple model right now. I don't want to use any load balancing. That's the next step. I don't want to do any scaling also. Next step. So there are many kind of configurations, and I just say create service. So when I'm looking at my service, I say view service. So what is happening behind the scene? That particular HTTPD container is getting downloaded from the Docker hub, and then it is getting set it up, and you will see that is actually pending state. Last status was pending. Desired status is running. So let's say what is happening. So if you look at this one, this is something which is running. And this is running on our EC2 instance, which is running on an EC2 instance managed by this cluster. And if you go to this task, and you will see cluster, container instance, instance ID, and you can go to instance ID and check some more information also. So I know that this is running on port 80. So if I just go to this particular instance ID, public IP, I should be able to go to the external link. So if I just look at the containers, I think it gives you this network bindings. And if I go to this particular port and particular IP address, then let's see what happens here. So it is waiting, and it is, you will see an Amazon ECS sample application. Now this application is now running on a container in Amazon ECS. Sorry, anyone tried that? I think one person was trying. Right. So what has happened is that, so we have set up this cluster. We created the service using something known as, we created task definition also, and that is running on one instance. So this is where it's running, and also it is having one default page which is configured, and that is how it works. Now, one of the benefit of service is that it will actually maintain desired capacity of kind of container instance, Docker container instances. So let's say I want to, I have basically stopped this now. Something happened. Just imagine that, you know, on Docker your EC2 machine, the container has stopped. Let's see what happens now. So if I go to my service, so if you look at this, active service count is 1, running task count is 1, and if I just say, I say stop all, it is saying, are you sure you want to stop all the tasks in cluster? It says the tasks that were started by service should be stopped by updating the service, because we know that this is going to start one more instance, that is Docker container. So basically it has stopped now. If I'm running, see if I don't see anything running, and if I go to this page now, sorry. Depending on caching and everything, it is waiting. But what is happening behind the scene? It has probably created one container by the time I hit this particular application. So let's go back. You will see it has basically ensured that this container is kind of running. So this is the benefit of this whole ECS model. And this is, you can really, if you want to really add additional containers, then also you can, increase the number of containers. So you can go to service and say that I want to increase, I want to, add additional containers. You can also scale your cluster. So if I go to my clusters, and if this is my cluster. The cluster is having only one EC2 instance, but it is also possible I can update the cluster. I can change the cluster settings also. So that is also possible. You can really add the cluster, then you can add additional instances running. You can run multiple tasks. So let's say I have basically running some other kind of task running. So let me go to my demo setup. Okay. All right. So there was some one more cluster which I created earlier. Okay. And if you look at this cluster, it is having one container instance. It is having one Fargate type and two EC2 type. Okay. And if I look at my tasks, so now there are 3 tasks running. So tasks are nothing but Docker container equivalent, and one is running as a Fargate, and another is running as another 2 are running as EC2. So that is something which I was running earlier. So depending on your use case, you might actually decide to go with Fargate. Fargate is the preferred option. If you think that Fargate has some issues, or you really want to go inside the EC2, what is happening inside the container. If you want to have that kind of mechanism, then you have to go with EC2 model. So I'll just show you, these instances are running. So these instances are nothing but the EC2 instance. But if I look at this particular Fargate type, if I just select this one. So this Fargate type basically will not result into any of the EC2 instances, but that is getting mapped to something known as ENI, which is created inside the VPC, and this is the public IP of that ENI. And if I go to this particular public IP, so I need to get what is the published endpoint. Yes, so it basically has some other default HTTP based application running as Fargate. So that's the whole concept of about this, ECS. In fact, I have one registration app also running on one of the cluster. If I just go to clusters, let me see. I can see that this is. If I go to my ECS tasks, I have. Okay, so there is a reg app is running somewhere. So this is on this instance task, and this is running on this particular instance ID. And this is the external link. So if I go to this external link, this is my Tomcat, and this is my workshop.register.html. So this is also running on ECS. So if you just go back to this particular example, so we created this EC2 standard, kind of first approach. And this is also still common. It is not that everyone has moved to ECS or EB. This is your first fundamental approach. This is the second, what we saw is EBS, sorry, Elastic Beanstalk. And third, if you are basically using containers, then we have used ECS. Now it is up to your, how your application is kind of built, designed, what's your kind of, project's requirement, what's your, architecture team is saying. Depending on that, you need to really use this approach. So is ECS concept clear? Any questions on ECS, or it is too complicated? Anyone? Anyone using ECS so far in your projects? No. Anyone who is using it?
Yes.
So you set up ECS cluster yourself, or somebody else set it up?
Someone else set it up earlier.
Okay, all right. Fine. So this is really valid only when you are using Docker containers, but Elastic Beanstalk and other model is valid for non-Dockerized mode also. See, for some of you, it might be a bit kind of complicated because if you are not really use AWS extensively, then you need to really correlate all these things. So without that, it will be very difficult what is happening behind the scene. In case if everything is working fine, then it's not an issue. But in case somebody has to really debug it, why it's not working, then you have to really understand what is going on behind the scene. And there are many features, like from the networking perspective also. So let's see what else on ECS. So this container agent which runs on each and every node, and that basically gives you some information about the container status. So how does this ECS know that this container? There is a mechanism by which this is going to happen, right? So that is where the ECS agent is going to run. Placement of tasks. You can also scale services. So that is something which we have seen in the case of auto scaling concept, and now this is also applicable at the container level scaling. So I think one point you should be very clear about, we are talking about two levels of scaling. See, AWS platform is created so that all internet scale companies can also use it very easily without really worrying about nitty-gritties. So here, when you talk about ECS cluster, actually there are actually two levels of scaling. When you talk about auto scaling and so on, that can happen at the EC2 level. So it means now based on my CPU load, average CPU load across my cluster, I want to spin additional EC2 instances. Let's imagine that somebody wants to really do a hot star kind of thing. Then dynamically they might want to add additional instances because the existing instances may not be sufficient. So what they will do, they will add additional instances. So this is called EC2 or VM level scaling. So you have scaled it. So you have basically some EC2 instances running. And when you actually started these EC2 instances, no containers are running. But typically when you spin up additional EC2 instances, you will also scale your container instances, Docker container instances. So what is going to happen? You can configure that now you're running web 4, please run 8 web containers. Please run app. In database, you're still having a database, you can't really just scale horizontal. So obviously database will have some different mechanisms. So in that case, what is going to happen? Then another web will come here, 2, 3, 4. App will come here. App here comes, here app comes, here app comes. So this scaling, this is happening at two levels. So this scaling is called container level scaling. Okay? And when you actually use Lambda, so what happens when there are concurrent executions are happening? Let's say Lambda is highly scalable. So somebody is going to invoke Lambda. Let's say your Lambda processing is taking less, for hypothetical sake, it is going to take 1 minute. So your one Lambda is actually serving. So Lambda is nothing but ultimately it's container. And that container might be running as a Fargate on Fargate. And then let's say you get additional request, and your Lambda service is going to spin up one more container. And that request 2 will be processed by that. So this is request 2, this is request 1. Request 2 will be processed by another Lambda container. Now again, that takes 1 minute. Have we lost? Can you guys hear me?
Yes.
Yeah, can you hear me?
Yes, we are able
Hello.
to hear you.
What about screen sharing? Can you see my screen?
Yes, it's a Microsoft team kind.
Yeah. Now what do you see? So let me reshare. Yeah, can you see my whiteboard now?
Not yet.
Is my whiteboard visible? It's okay.
Yes, yes. Now it is visible.
Yeah. So what I was speaking that there are two levels of scaling. So one is called container level scaling. So when when you scale your Docker containers from 4 to 8, that is called Docker level scaling, and the VM level scaling which we have seen. So this VM level scaling as well as container level scaling typically works in hand. Now, when you are working with Lambda, see, let's say Lambda function is taking 1 minute. Request comes, so request 1 comes. This is processing, and after let's say after 10 seconds, another request comes. Now, in that case, it is going to spin up another Lambda function. It is going to start one more Lambda. And that Lambda might be running using Fargate. You don't know how it is implemented internally. So when another request comes, it is going to spin up one more container. So that is something which is managed by Lambda service for us, and that is called container level scaling. So we're talking about two different levels here. That has to be very clear. Because you can just, let's say, after adding these many instances, you want to add one more container. So from 8 to you have to make, let's say, 10. So what happens, like, your 9th one comes here. But if containers do not have sufficient capacity, because there might be some lot of constraints, it will not be able to launch any additional containers. So in that case, you have to really spin up your EC2 instances behind the scene. And EC2 instance scaling is like time consuming, because to launch one VM, you have to basically assume that it will take around 3 to 4 minutes at least. But when you go for container scaling, then the container scales in seconds, in milliseconds. And that is why people actually generally over provision this EC2 capacity, and they just play with this container auto scaling. That is what a lot of companies are actually doing. In fact, if you look at this, I was talking about this Pokemon Go, and there is some interesting case study on Pokemon Go, and Pokemon Go actually runs on containers. Without that, they wouldn't have really achieved what we're trying to achieve, and it's a massive scale. It's an interesting case study. If you find it on Google, just read that. And Google, like we use Google, right? So this Google platform is heavily container based. So whatever we are looking at, all the service like Gmail and everything, internally behind the scene, they use containers. So a few more points related to ECS. So you'll not go into this details of service load balancing. In Fargate, we have seen. So in the Fargate, you don't have to do much. So whatever we did for launching our EC2 based container, the same steps, but you have to just say launch type is equal to Fargate. Now this is something, those guys who are familiar with Swarm, Kubernetes, and so on. So what is this? These ECS, Swarm, and Kubernetes, they have the same purpose. When I say same purpose, like we just saw how this cluster, ECS cluster is going to maintain all the EC2 instances. Sorry, it is going to maintain all the container instances at desired service. And obviously there are many parameters, like you can configure memory for each, you can configure CPU utilization for each, and so on. But ECS is not the only solution. Now, even if you're not familiar with other kind of stuff, So just give you a high level perspective. Whether you want to use ECS, whether you want to Swarm or Kubernetes, and this has been like a lot of discussion point for various companies. And let's see. There is a little bit of history here. So now this is a very high level perspective. So obviously you need to dive in deeper into technical details. But if somebody has to make a choice, then some time back there was Docker, and Docker basically had Docker Swarm, which is built in. So when Docker started, they had another kind of installation required for Docker Swarm, and subsequently they made it very simple. So Docker Swarm is the easiest to use. It's natively integrated into Docker now. So by default, you can use Swarm mode. And then we have this Amazon ECS. Now Amazon is, we know that we have Amazon and hello, can you hear me?
Yes.
Can you hear me? Yeah, I thought somebody got disconnected. All right, and Amazon ECS is trying to work around, basically whatever Docker is providing, they just, provide some wrappers around it, they try to enhance it, but they are basically following what Docker is doing. And Kubernetes is a very old platform, which is like 15-year-old plus platform used internally in Google. And what is happening earlier, sometime back, Amazon was like, no way I was looking into Kubernetes. But after some time, what happened is that Swarm and Kubernetes actually added a lot of features. ECS was actually trying to do catch-up game because this is a technology which is not kind of built by itself. And as of now, what is the reality? Now Kubernetes is actually way ahead. So Kubernetes has become a de facto for implementing container loads. So if you want to really switch to Amazon ECS, I don't know what is happening with other companies, but you have to really make a kind of hard kind of choice, because one plus point of Amazon ECS is that because it's Amazon, so Amazon might integrate a lot of other services with ECS. So that is the kind of one point you should remember. But you cannot really run Amazon ECS inside your data center. So like now Amazon has something as Outpost that is very different. But Kubernetes is something which you can use. Kubernetes is hard to actually set up if you want to really have a production grade environment on premise. And that is why Amazon has given you something known as EKS. So if you go to AWS console, now there is one more service which is called Elastic Kubernetes Service. So now it's so my view is that it is going to be Kubernetes is de facto now. So unless you have some specific reason, people will not actually use ECS. So we're not going to look at Kubernetes. Kubernetes is a separate topic altogether. But it's basically all things whatever we had looked at ECS, similar facilities provided by Kubernetes. So let me pause for a minute here. And let's do a quick recap, because we have discussed, or at least I was explaining various concepts. So let's understand whether few things are clear or not. All right. So what are the reasons for using Elastic Beanstalk? Anyone would like to start? I will actually pitch in between. What are the benefits of Elastic Beanstalk?
A complete set of environment is ready for us.
Yes, anybody else? That's correct. Yes, Elastic Beanstalk. So what developers need to do as a programmer? What is your job in Elastic Beanstalk? What's your major activity?
Deploy the application. Just means environment is ready, so we just need to upload our code or whatever our application is.
Yeah, that's correct. So whatever application, let's say you're building Java-based application, Tomcat-based application, then you have to just upload the WAR file. If you are using Docker, then you need to appropriately upload the Docker file and so on. And is it possible to create a load balance environment using Elastic Beanstalk?
Yes.
Yes, that's correct. So Elastic Beanstalk provides you load balance environment, like HA environment. So these are all presets. So you can use single instance model, you can go for load balancing. And when it sets up many things. So the key is once you understand load balancer, EC2 and auto scaling, three things are very important. So to understand Elastic Beanstalk as well as ECS. So that's the benefit of Elastic Beanstalk. It supports many deployment policies. So like it has got rolling deployment, it has got blue-green deployment. So what happens in the blue-green deployment? This is just a concept. So what happens typically in blue-green deployment?
Yeah, one instance is always running in the environment, and while others we can patch it offline.
Yeah, that is for the rolling deployment. That is called rolling deployment. But in case of blue-green, what happens is that it is going to create another set of instances.
Right.
So it is another set. Yeah, another set, and that on that it is going to set up that application. It is going to test it. So you will get a different endpoint altogether. So whatever is there in your kind of setup, all those things repeated. So if you are spending X amount of dollars in one Elastic Beanstalk environment, and if you are using this blue-green deployment, then you are going to spend like not exactly double, but just assume that for that environment is going to run for, let's say, 15 minutes. So whatever is the cost for that 15 minutes is there for one single environment, you have to pay double of that because entire set is kind of recreated. All right, so that's basically Elastic Beanstalk. And then we started looking at this ECS. And what are the benefits of using ECS? Okay, so can I install an application which is non-Docker based using ECS? Non-container application?
Yes.
Anybody else want to give a different opinion, different answer? So if you are using ECS, it is only meant for container workload. If you don't have a container, then you can't really use ECS. But in Elastic Beanstalk, you can use non-container based workloads also. So that is something which you need to remember. And while setting up this ECS, what are the kind of steps? What are the broad steps? Logical steps, just tell me logical steps. Don't have to really tell me all the configuration. It is not possible to remember all those things. What do we do? Let's say if I want to run a container, simple Docker container on ECS. Yeah, so the steps are like we create cluster. That's number one. Then, yes, anyone?
Second is the task definition.
Yes, second is the task definition.
And third is service.
That's correct. So you create a service. Yeah, that's correct. So these are kind of broad steps. And we saw how ECS works internally. ECS uses EC2 auto scaling, load balancer, and so on. And service will maintain the desired number of instances. And there are various algorithms by which it is going to decide on which EC2 instance I should actually place this task. What is the other launch type we have seen? One is EC2, other is called, what is it called? Fargate, that's correct. It's Fargate. So Fargate, what is the advantage of Fargate? What's the benefit? So when you use Fargate, then you don't have to really manage any EC2 because you don't have to spin up auto scaling. Everything is done behind the scene by ECS service. So ECS is going to launch something like EC2 somewhere, but for us it is going to just give an access to a network interface. Network interface is nothing but the elastic network interface which is attached to an EC2 instance, and IP address is attached to a network interface. And that is how we will basically be able to access our application. All right. So let's look at something known as cloud formation. So let me share my screen. Just give me a second. So we have seen this ECS and then Elastic Beanstalk, and it basically uses something known as cloud formation. So let's look at the conceptual part. So I'm just sharing my screen. All right, can you see my screen? Is my screen visible?
Yeah.
Okay, all right. So let's talk about CloudFormation. So CloudFormation is a service which is provided by AWS, which is used quite often, and I think most of you are already using it. So for those guys who are new to CloudFormation, let's understand basics. So if I ask you that, okay, please document your architecture or AWS architecture and share with me. So typically what you will do, you will actually go to AWS, understand various elements. You will create a diagram in various tools. Maybe you can use Visio, you can use drawing tool. You create a nice diagram the way I have created in the demo labs document, and then you will try to put as much information as possible over there. Now that is something is good for understanding purpose. I can understand, but it is kind of very difficult to maintain whatever is the state of the current AWS environment in the document. That is challenge number one. Secondly, if I want to really say that, okay, fine, you have created this document, I like it. Now, what you do, you create the same architecture, same implementation in another AWS account. Then you start referring the document, and then we start referring the document, and while actually start creating that implementation or doing like EC2 launching, then you will have a lot of questions. So what should be the security group rule? Should I open port 80? Should I block the port? Some 9090 port or some odd port in the network AC. So, and it's going to be very difficult to document each and every step. So in that case, what you can do, you can create something, some file, and you can say that, okay, this is my file, and I'm going to have all the details captured in that file. And that file is nothing but your CloudFormation template. So if somebody says, okay, give me the CloudFormation template, you have to just give that file, and then you can use that template to create something known as AWS resources. So let's understand this, and this is also called infrastructure as a code, because you can really store this file in, let's say, GitHub. You can do version control and so on, and you can precisely know, what was my version or what was the configuration on day 1 or 6 months back using files which are there in the GitHub or in your Git repository. So let's look at CloudFormation. It's a service from AWS to aid faster infra setup and deployment. Now this is targeted to a different audience altogether. Now this is typically targeted towards system operations. Those may not come from the development background, but happening now is that a lot of development or even developers are actually using this CloudFormation. And in fact, your team or your the kind of group which is attending the session, if a lot of you are actually using it, then yes, you're moving towards DevOps kind of thing. So AWS CloudFormation requires you to have a lot of understanding of AWS nitty-gritties. In contrast to Elastic Beanstalk. Elastic Beanstalk is something which is primarily targeted to a developer audience without knowing the nitty-gritties of AWS. But this is on the other side. If you want to really use this, you should really understand how it's structured and so on. It's an easy way to create, update, and delete the infra. See, in our account or in your even AWS console, if you go to console, there are a lot of resources are created. If I say that clean up all the resources, then you have to, how do you do that? You have to really literally go through various resources and start cleaning those up. When I say cleaning up, you want to terminate it, you want to stop it, delete all S3 buckets and so on. So that is something which is time consuming, because if you look at this, there's only one region. And if you have created resource across the region, then it is going to be very, very tricky. So if you're running a significantly kind of large scale environment, then you can't really manage this manually. So that is where this cloud formation comes into picture. So what you can do, you can create an infra called cloud formation stack, JSON YAML based scripts, not scripts, actually these are templates. And then you can just use this template so as to create resources. It's a free service. So in AWS, they have a philosophy that for tooling, they are not going to charge. But for all the resources which are created by the tool, they are going to charge. So cloud formation service is free. Elastic Bitstock service is free. Cloud9 ID is free. VPC is free except NAT gateway and VPC endpoint. IAM is free. So there are a lot of such kind of things which are kind of free. And then it's available in all regions, all services, most of the services are there. So this is what happens. So as a DevOps person or a SysOps person, you create a file which is, let's say, JSON formatted file, which is a template file, and you can pass all the parameters. So let's say if you want to launch an EC2 instance, we know that we want to pass various informations like what all the information, such as instance type, AMI, security group. So some values could be fixed, but for some you might want to pass as a parameter. So you create this file, and then you go to CloudFormation service, submit this file to CloudFormation framework, and then it is going to create all the resources, and those resources are grouped as stack. So it is going to create stack, update the stack. There is error, it is going to roll back and so on. And it is going to configure AWS services, and those configured AWS services are called stack. So when you are having this logical grouping, you can really manage this stack. You can just go to CloudFormation and say, I want to delete the stack. Then all the resources created by that CloudFormation will be deleted. So that is the concept of this CloudFormation. And that is why this is called infrastructure as code. And Terraform, somebody said Terraform. So Terraform is also another alternative. Terraform is not from AWS. But if you're working with multiple cloud platforms, it might be easier to use Terraform, because once you understand Terraform, you can use the Terraform knowledge so as to do the deployments in AWS as well as Azure and any other platform. So Terraform is also kind of very popular, but there are many other ways in which automation can be done. You can use Chef, you can use Puppet, and a number of things. So template contains many things. So let me quickly give you a walkthrough of this.
Hi, Amod. Hello.
Yes, please.
Yeah.
Yes.
Can you explain more about like stack? Like stack is a version, what we can say in simple term.
No, what happens is that stack is, let's say you create resources, you create an EC2, and you create S3. So that is a set of resources, right? So let me go to whiteboard. Okay. So what happens, let's say if I go to CloudFormation and I'm going to create a template. So let's say using the template, let's not worry about the exact syntax. So I'm making a template, and in this template, I'm creating an EC2. And I'm going to create an S3 bucket. And when I give this to CloudFormation service, let's say there is a CloudFormation service, it is going to create physical resource. This is all logical resources here. So it will have an instance ID, EC2 will have instance ID. Then it will have a corresponding IP address, private IP, security group, and so on. Similarly, we will create a bucket. So if you want to really, group this together as a whole, as a unit, you just name that as a stack. So if I just say, I'm going to group this set of resources, and what is the kind of, logical name, or I want to give some name to this group. So this is called a stack.
That means.
So when you create this, you create a stack, and let's say if I want to delete, so what I'm going to do, I can basically go to CloudFormation and delete this stack. So when I'm deleting the stack, the resources will be also gone.
So can I maintain multiple stack on AWS?
You can create multiple stacks.
Oh.
Okay. See what happens, once you use this template and you have created this in one region. So typically you want to create a replica. So you want to create a replica because you want to create a replica for a development environment. Then you can just create another stack. And you can just say that dev stack, prod stack, and so on. So just resources are various resources are created in it. So I think it's very easy. So once we see an example, it will be very clear. I will switch to my presentation.
Can we add dependencies? I mean, say when you just said that we can have multiple stack. So say suppose is only after the dev stack is successful, then only go for prod stack, something like that.
I need to check, but I think that should be possible. I have to just refer my notes and just. So I'll get back to you, but I think that should be possible.
Okay.
But for resources, definitely it is there, but I think there has to be provision in which I'm just not recalling the exact name, but that should be possible. Because this is a common case. When you want to create something, it makes sense to have that kind of feature. Yeah. Any question? Okay, so let's look at the sample template. So this can be created in JSON. So this is a sample template with single resource. So you can say AWS template format version. Now this is a version which is fixed in the sense you cannot put any arbitrary value. And while recalling our IAM policies, we create version. We put a version. So that version is nothing but a last typical update. So if Amazon updates, let's say 2020, it's going to give you 2020 here. So it is possible to use specific versions. In some cases, you want to really kind of use earlier version of API. Then that is something which is possible. Description, a sample template, resources. So what do you do here? You say that I want to create an EC2 instance. And you say type AWS EC2 instance. You say properties. It's the image ID. It's AMI so and so. This is AMI ID. Then instance type is T1 micro. This is a bit old. Earlier there used to be T1 micro, but you can say T2 micro, T3 micro. You can specify the key name. And then you specify block device mapping. So device name, dev/SDM, and what is the volume type? So there are different volume types. If you remember, we created DBS, and we can also create different types of volumes. Provision IOPS is something which is going to give you consistent input-output performance. So it can do so many IO operations. Typically for database, very transaction-heavy database, you want to have high IOPS. Then you can say 200 is my IOPS. The delete on termination equal to false. It means, well, don't delete this instance is deleted. So keep my EBS volume intact. And the volume size is 20. So this is something which you can specify. And if you look at this, all the parameters which you can specify through console, through CLI, all those things can be provided using CloudFormation. So AWS keeps updating this, and they will provide you all the things which are necessary to create this resource. Now, once you have this, then you can just submit it to CloudFormation, and your EC2 instance will be spinning up. And you will notice that we have not specified any VPC here. We have not specified any group, so it is going to use the default value. So this is with single resource. Now let's say you want to create a EC2 instance as well as create, let's say, Elastic IP, and you have this Elastic IP which needs to be associated with this EC2 instance. The first part is same, but if you look at the second, it is creating AWS EC2 EIP, that is Elastic IP, and it is saying, fine, it is going to create an Elastic IP, but it is going to be assigned to which instance? It says reference, it is going to refer to my EC2 instance. So even you can basically put multiple resources, and here there is no ordering here. So AWS is going to figure out which resource to be created first and which resources need to be created second. So if you submit this to CloudFormation, then you can basically get this Elastic compute or EC2 instance, and it will have an Elastic IP. So that is what this template looks like. And so you don't have to worry dependency. You don't have to worry about order. Let's say you put some more elements related to VPC. So in that case, now AWS is going to figure out, the CloudFormation is going to figure out that it has to create the VPC first before launching an EC2 instance, because this basically gives them idea, this reference element, and it can build a dependency structure internally. So that is the plus point of this. So let's look at the template anatomy. So it's a very simple. Again, it has got many kind of parameters, many kind of you can put many conditions, you can do path description, metadata, and so on. So the only mandatory thing is resources. So if you are creating a template, the only mandatory thing is resources. Even AWS template format version is optional, and the other type, other things which you want to really use depends on various kind of context. You can pass parameters, and this transform is basically useful in case of the serverless application and so on. So let's see how to use this one. So meanwhile, let me stop my screen sharing for a second. So if you have Eclipse, then you need to start Eclipse. So I'm going to start my Eclipse also. I'm just going to pause my, I'm going to stop my screen sharing. So I'm just opening my Eclipse. Because Eclipse has this kind of nice kind of intelligent support for writing your CloudFormation templates. Because in order to use CloudFormation, you have to really type all the parameters, all the kind of attributes, and it is not possible to remember all those things. So let me start my Eclipse. So I'm going to amend my demo document. I'll just say, I'm just sharing my screen one sec. right. So my Eclipse is still launching. It takes time. But if you go to this documentation, so okay. Let me just check the formatting. You will see on page number 26 using CloudFormation. And I will also share some of the sample CloudFormation templates which are there on my GitHub repository. Okay. So let's start with S3, which is very simple to understand CloudFormation, how to use it, some basic mechanics. So let's go to Eclipse. So if you have Eclipse, then you can just go to CloudFormation editor, something like that. So you can create any project. Sorry. And let's say I want to create a new project, or I can use the existing one also if you already created one project earlier. So I created some project earlier. So I'm just going to use JD workshop 3, something like that. And I can use the existing one. And let's say I want to create a file. So I'm selecting any project. And let's say I want to create a template. So why I'm going back to Eclipse, because it has got this integration support, and I say other. And I'm going to say Amod JD S3. Sorry, I need to just say select test file. If file, I say Amod JD S3 .cf, or I can just say .template. So it is creating a file, and you will see that on the left hand side it has because I have saved it as .template, and if I open this, I can open with I'm opening with Amazon CloudFormation template editor. So alternatively, you can go to other and just search on Amazon CloudFormation. It should appear over here. And I'm just going to use this. And let's say I want to create a S3 bucket. If you come to this particular file, I'm just going to say, and if I just say double quotes space, it is going to give me all the options which are there in my template. So I'm going to say AWS template format version. I'm just going to say enter. If I just do control space 2010 0909, and then I can create resources section. So in order to follow along with me, so if you look at this sample bucket, so this is something which I'm going to copy and put it inside my Eclipse ID. I'm going to modify some values. So I'm just going to copy paste. All right. So this is my format version, and then what I'm doing, I'm saying resources. So this is just a logical name. This could be my JD bucket. It's logical name. So this logical name is used for cross-referencing within the template. Type is S3 bucket. Properties, I'm just going to say JD.cf. So I understand that this is created through CloudFormation. Now, if you look at the various properties, if you just do this, then you'll get many properties. So whatever you can see through console, access control, bucket encryption, then object lock configuration, tags, website configuration, and many such things which you can configure using CloudFormation. And you can get a complete list by going through AWS documentation. So let me switch to this link. So if I load this, so you can create this, and then you will look at the syntax. So it has got properties, access control, bucket name. Then if you want to put something additional information, and then if you just click any of these configuration like lifecycle configuration. So lifecycle configuration is something which allows you to move your objects from one storage class to another storage class, or you can delete your objects. So if you just click on that, then you will see some settings, lifecycle configuration, and then you go further. It is going to give all the things which are there. So again, rules. So lifecycle rules, you have to click on the rules. Then you have list of rules. So that is what something which you have to give. And whatever is possible using JSON, it is also possible through YML. Now YML is also pretty popular. So now if you are using Docker world, then you're already familiar with YML. But I'm using JSON because it has got its IntelliSense support. But you can find some editors where you can have a YML supported through IntelliSense. So all those configuration you need to specify. So you need to basically look up this documentation and figure out what are the properties you want to set. So this is step number 1. And what you can do, you can actually put this inside the Git. So that becomes your version. And then you can take this, and I'm going to just go to console now. Go to console and look at CloudFormation. And if you go to your account, you will see that so far you may not have really explicitly created any of the stacks. But you will notice that, at least in my case, I could see 3 stacks. And if you look at these one, these are all created today. ECS container, AWS AB. So all those things are there which are created using CloudFormation. So I want to, we will look at that one of the sample CloudFormation. Then I'm going to, let's say I have to create stack. Now again, it is like evolving. So it is also possible to, now this was, we'll look at this import resources as a concept, but I just want to create with new resources. This is standard. And then you come to create stack. So what you need to do, you have to create a template. The template is created by us now. You can also use a sample template. You can use designer and so on. And then I'm basically uploading the file. It is also possible to use this S3 URL. So what you can do when you are using this, I think nested stack, something like that, then you can keep all those files inside the S3. But it is also possible to keep all the files on S3. And then you just ask CloudFormation to read that from S3 bucket itself. But in this case, I'm just going to upload the file, and I'm going to upload the file. Now this file is residing on my machine. So I have to go to the appropriate location. So I have to basically go to this particular file. So this is my properties, I will go to a particular folder. So this is my folder. So JD workshop Lambda, this is my. So this is my path. So I'm just going to copy this. And I'm going to move to another folder. So the copies, or that's fine. I can just copy it from here itself. It's a bit long name. So I basically go to this and I say choose file. And I say Amod, Eclipse workspaces, then JD workshop 3. No, sorry. What was that? JD workshop Lambda. Lambda 2. Sorry. Too many files here. So now what I'm adding this, and I can view this in the designer also. And I'm going to click on next. We'll come back to designer shortly. I just click on next. And this is a stack name. So I can say, and to create a stack, I'm saying Amod JD S3 stack. And it doesn't accept any parameters. Now you can also take, bucket name as a parameter and accept that as a. And click on next. You can give tags. So I'm just going to say purpose. Or let's say name JD workshop. And permissions, just keep everything blank. You understand I am role now. Then there are some advanced options. So let's ignore that for the time being. And so click on next. It is also possible to estimate the cost because you are creating the resources. And that's it. You just click on create stack. So what is happening now? I come back to the stack screen. And it is saying timestamp, logical ID, status, create in progress, user initiated. So let me refresh my screen. So it basically says one more creating program and status resource creation initiated. Click further and you will see create complete. So this is my logical ID. And it has created my kind of, my expectation is that it should create my S3 bucket. So if you look at our stack, then if you go to resources section, you will see logical ID. This is nothing but coming from the template. Type is bucket. And you'll go to physical ID. You click on this particular link. It will take you through to the S3 screen, S3 console. So if you look at this one, so this is a bucket which is created. So if anyone is trying, they should also get the same kind of bucket created. So this is the way the entire process works. And you can do many operations with stack. You can update the stack. You can delete the stack. So I will just go back to my CloudFormation stack again, CloudFormation. So this is something which I just created. Now, if I select my stack and if I delete it, then my S3 bucket will be deleted. If I delete, it is going to delete all stack resources. So to be very careful with delete stack. And if you basically you don't want to delete certain resources in the stack, then there is a concept of something known as deletion policy. So you can say that I don't want to delete these resources. You can identify that as using deletion policy. That is also possible. Deletion. So if you want to delete stack but want to retain certain resources, you can use deletion policy. I just include a link also here. Now, typically, what happens when you are actually creating the VPC and so on, a database, you might want to turn off all the, you want to, let's say, destroy all the EC2 instances, but don't want to delete all the kind of databases and so on. So it is possible to say that don't delete the database. So depending on the kind of resource, the deletion policy options might actually be different. So if you create a S3 bucket, and if you set the deletion policy is equal to retain, so if I come copy this and put it inside my template, so if I just put it over here, deletion policy, so retain, and then what is going to happen if I upload, like if I want to, I can create a new stack, and then, when I delete my stack, then this will not be deleted. Similarly, if you want to use YML, the same thing can be done in the YML. If you look at the JSON versus YML, the YML is much cleaner because there are no extra these kind of brackets, but it is very sensitive to the spaces and so on. Then for RDS, the default policy is snapshot. So that is something which you need to really kind of understand. So depending on your requirement, you have to set the deletion policies appropriately. So if I go back to my CloudFormation stack and I just delete, it is going to delete my resources. So I'm just going to delete in progress. And delete complete. So delete is complete. So if I go back to my S3 bucket now, then I should not have that particular S3 bucket. So I think that was named as Amod Kadam.jd.cf. If I search my bucket, that's gone. So this is the way the CloudFormation in principle works. In theory, that's a concept. Now, if you look at some of the stacks here, so this is a stack which I created. When I say when I created this using ECS. And if you look at this template, and if you look at the number of resources it has created many resources. They're logical resources, autoscaling group. Any question? The instance LC, security group, and so on. Created many resources, and you can really see the template over here. See the template. And somehow they improved the UI significantly. And you can see this in as a kind of YML template. You see all the parameters here: ECS cluster name, AMI ID, instance type. These are all parameters. So when you actually go through that ECS console, it basically presents you the CloudFormation template, and you are basically giving the values inside that, and then it picks up and execute this one. So there are a lot. This is a very lengthy one. And if I look at this in the designer, there's a designer which comes into AWS. So it is a visual model. Whether it's helpful or not. Yes, please.
मैं देख लूंगी उसको, अभी 6 बजे से कॉल है ना तुम्हारा?
Yeah, okay. I think there is some project work is going on, it seems, or the project calls. All right, so we'll just have another 5 minutes. So what happens, if you look at this particular designer, I don't know whether if anybody has used this designer, I find it very cumbersome to use. But this is at least some usual presentation. What this template does. Somehow it is not very intuitive. Hopefully they will improve it. So even it is possible to create this using designer and instead of typing JSON. So if you look at this, it creates public subnet in AZ3, it's public subnet in AZ2, then it creates ECS spot fleet, it creates auto scaling group, it creates launch configuration. So all those things are kind of there, and you can see all the things in the template below. So this is the template. You can switch between JSON and YML. So this is the way you have to really code it, in the sense you have to understand and you have to really type it. So generally, what you do, you take this something which is readily available and customize it. You don't start from the scratch. So that is the model of this. So to give you some better example from understanding perspective, to understand this, so there is one more template I have created in my document. So that is for VPC. So we have seen VPC creation earlier, gone through many series of steps. But if you just use this VPC template, then your VPC will be created in like few seconds. Obviously, if you're using NAT gateway and so on, it will take like a couple of minutes. But apart from that, it's very quick. So I'm just going to copy paste this, and I'm going to say I want to put this in my file. This is my Amod JD VPC dot template. I'm just going to copy paste this one. So it looks much cleaner in the console. Sorry, in the Eclipse editor. So I'm just going to. So I'll just quickly walk through what this is, and then we can try that maybe tomorrow. All right. So if you look at this particular template, then what we have, this is a template format version. The description: building a VPC from scratch with CloudFormation. And how do you start building this? The best way to start it with resources. You don't start with parameters. The way I work with, I start with resources. And then while building, let's say I want to create a VPC. I say VPC type is AWS EC2 VPC. Properties: enable DNS support, enable DNS host names. CIDR block is my IP range. What are my tags? So I'm saying application is the key, and the value is I'm basically giving a stack name. I'm basically